Hello guys, welcome back again on the NLP crash course, which is where we are just giving you the chance to become the LLM engineer. So guys, sorry for delaying the 2 weeks due to the some constraint. We are not able to record the session. So on this week, we are starting again with the session for which is become the hands-on session on the large language model, which is coming the next crash course. So this NLP crash course, this is the fourth session, and today we will cover about the lexical processing and the syntactic processing in this journey. So stay with me. So guys, you are able to see the screen, right? So today we are going to cover the hands-on session. So basically, where we are demystify the lexical processing, which is a journey of the NLP techniques. So hey there, tech enthusiasts, welcome back with another captivating session where we unravel the wonders of the natural language processing. So today we are deep diving into the intricate world of the lexical processing and its fundamental techniques. So just imagine one picture where you are at the library surrounded by shelves stacked with the books, all shapes and size. Each book presents the piece of text filled with the word waiting to be deciphered and understood. Right. Now imagine if you could break down that words into the smaller and more manageable units, much like a sorting games on the sands on the beach. That's precisely what lexicon processing does in the realism of NLP. So let's embark our journey and explore the two techniques that form the backbone of the lexicon processing. So on the screen, you are able to see that the fundamental component of the natural language processing, which include the handling and processing of the textual data, word and token labels. First is a tokenization. So on screen, you are able to see that there is a big window which is contain the word. We are moving to L. Okay. On screen, you can see that this is a fundamental of original text. And then after you can see that on the sub branches, we are splitting that sentence into the multiple things. We are moving to LA, which is known as splitting the word with the white space. Right. Next, we are splitting the BR word with the inverted comma, which is also the known as a splitting. So ultimately, the splitting into the word from the prefix side, exceptions, suffix side, exceptions, and done. So these are the process of known as a tokenization. So what is the tokenization? Tokenization is a key to breaking the down complex puzzles into its individual pieces. So it is basically known as a deselect the text into the smaller unit, which is known as a token, which is served as a building block for the natural language algorithms. So think of tokens as alphabet blocks that lay the foundation for the construction sentences, paragraph, and entire narratives. So with the tokenization, we can tackle the myriad of the NLP task from the text classification to sentiment analysis. So with the precise and finesses. So basically, let's see the code, how it works. So you are able to see that here we have imported one library, which is known as the analytical library, as we have already seen this in the previous session. So if you are not familiar with that, you can go on that session and see it again. So here in the first block, you can see that we have imported the analytical library, which stands for the natural language toolkit. Then we are trying to download the Punct resource. Punct is a module within the NLTK that is responsible for the tokenization, which is a process for breaking down the text into the smaller like words and the sentences. So when we are running this, so first of all, let me connect. Once it will be connect, we will run this and we will download this Plunk library, which is responsible for run and breaking down the sentence into the chunks and the words. So it is connected now, and let's run it. So now you are able to see that Plunk is downloaded and stored into the root directory. and it is also unzipping that. Now, on the next step, what we are doing is we are trying to import the word tokenizer from the NLTK tokenize module. Right, so this word tokenize is a method which is used for the tokenizing the text, particularly specifically breaking down it into the individual words. So in the next code, you are able to see that we are just using a one sentence, which is a sentence is like tokenizing is a process of breaking down the text into the smaller unit, typically the words, the words, which is called a token. So we are splitting down these words, okay, of this particular text. So we are passing this text. So here you can see that we have defined the sentence and stored into the string one variable. That variable we are passing into this function which we have called from the NLTK tokenized module. So once we will run that, we will getting this kind of the list, which is known as tokenizing the word. So you can see that it is returning all the word which is escaped by the commas, and the final output we are getting. So here basically the text contain the sentence about the tokenization, right? So here we are tokenizing the sentence using the word tokenizer function, which is stored the result as a token. So here the final result we just stored into the tokens, right? So this is basically known as a tokenization. Second concept is basically known as a normalization. So what is normalization? So normalization is basically known as a transforming the text into the harmony. Okay, so what is a harmony? So let's say normalization, imagine on that way is like normalization is much like tuning the musical instrument, harmonize text into the standardized format. So it is something encompasses into the two distinct techniques. First is basically known as a stemming. Second is a lemmatization. So stemming, which is famous for trimming the words. So something like we are trimming down the words. You can see that here we have example of change, changing, change, changer, changer. Right. So here we are trimming down the word of suffix values. Right, so suffix is basically the end of the character which is repeating at after particular common words. Okay, so let's say change. Here we are removing e, ing, es, and ed and er. Okay, so here we are removing that all the words, and ultimately the whatever is common between all the words which is remaining known as a change. Right, so here stemming trim the word down into the root form. So here change is a root word, while lematize, which is talking about the change, right? So lematize is trying to refine them into their dictionary lemma. Dictionary lemma is into the dictionary style word, ensuring that this linguistic coherence and clarity, getting the clarity. Okay, so these is basically the two techniques, stemming and lemmatization. Or if you so let's say if you want to understand with some analogy. So imagine that you are in the garden. Okay, you are trimming down overgrown bushes to reveal their natural beauty. So that's precisely what stemming does. It is prune the word to their essence, ability sometimes producing the quirky result. On the other hand, lammatization is like a sculpting, which is like a masterpiece, right? We telling that is refining the word into the purest form, most refined form, and ensuring that linguistic elegance and precision, right? So let's run the code. Over here you can see that stemming. So stemming is basically nothing but we are removing the suffix from the word and reduce them into the root form, which is known as like chopping the words at the end of the end of the words. So you can see result would be like this. So let's run the code. So over here you are able to see that we have a one like we have imported analytical stem. Stem is basically the module where we are getting the different kind of the stemming technique, right? So here first technique is a Potter stem, right? So we are importing the Potter stemma class from the analytical library, which is a popular stemming algorithm. We then initialize the instance of the Potter stemma class. You are able to see over here. We are initialize the Potter stemma class, which is directly called the object of the stemma. So next we are defining the list of words. List of words include running, easily, cat, attractive, and programming. So in this list of words, we see that it is a contain the different kind of the word length. right? Next, we will use this list of comprehension to stem each word using the stem method. You can see this is a stem method we have. Stem method we have, right? So what we are doing is by using this object, inside this object or Potter stem class, we have one method which is a stem. So here we are using a for loop to take it, like taking each word to convert that into the root form, right? So it's something like chopping the particular word and end words, right? So ultimately, whenever we are running, it is returning the stemmed words. Once it will return, what we are doing is we are just printing that original word and the stem word parallelly, so we can see that, like, okay, how is stemmed. So here you are able to see that in the running, ing is removed and ning is removed, and it's come into the original word run. Same way, easily is inside the easily, y is removed and converted into the I. Cats is removed and converted into the cats. Attractive is converted into the attract, and the program is removed into the program. So stemming, basically the stemming is reducing the word to their base form, but it may not always result in the real word. So that is called, so here in the example we have seen that, like, easily is not easily is easily, right? So that is a stemmed word, which is not the valid English word, sometime we can say. So always doing the stemming is not always a good choice. But yeah, every when you want to standardize this word, we are go for the lemmatization technique. So what is lemmatization? So lemmatization, I already told you, it is convert the word form into the dictionary form, which is called lemma, which is ensuring that your resulting is a lemma, is a valid English word. So lemmatization is a standard way we can say that, like, it's convert your any kind of the word into the natural root word, which is in the dictionary form. So dictionary form of the word is known as a lemma. So inside the so let's see the code. So in lemmatization, basically we are able to see that, like, we have imported the analytic library again. But here we require two more: WordNet corpus and another is average perceptron tag corpus, right? So these are the corpus which is used as a dictionary, right? And this is a collection of the dictionary where we are using as a supporter to just do the lemmatization, because ultimately we require the dictionary, right? So I am downloading this dictionary by running this code. So here you can see that these two dictionary will be downloaded successfully. Now over here we are able to see that we have imported the two libraries, right? So we have imported the stem, so which is a WordNet lemmatization, because ultimately we are using WordNet library over here. And second one is a WordNet dictionary, which is a corpus, right? So we can say it's a dictionary which we need to load. So inside this code, we will initialize the word lemmatization class first. These way. So basically, why we initialize? Because these word lemmatization is a class, so we have to create the object to understand the definition meaning of the word. So that's why we are converting, and we want to extract that root word which is come from the dictionary. So WordNet lemmatization will return us that. So first of all, we have to create that class. So that's why we have created the object lemmatization. And then after, we have defined the list of the words which we have already defined above. So these are the list of the words. Okay. Here I have defined one function which is known as a part of speed tag words. So here what I am doing is I am passing the different word which is converting into the uppercase and given the tag. So let's say on the tag dictionary. So basically what happened, I defined one function which is known as get wordnet pose, which is returning you to, which is helping you to map the part of the speed tag to the wordnet tags, right? And finally, after defining that class, what we are doing is we are lemmatizing each word using the lemma method in word tag lemmatization. You are able to see, and it is returning the lemmatization. So how it works? So basically, this list of word, right over here, this list of word. So basically what happened, this list of word is coming to these words, right? So in this word, basically we are, it is, so the list is already provided over here, right? Okay, so in this list of words, you are able to see, right? In this list of word, which is contain the 5 word, right? So we are taking every single word here and we are transferring that word, right? And what this word is doing, this word is coming over here on this function, get word pose limitizer. So get word pose limitizer is our this function, and inside this function, it is returning the tag dictionary. So let's say this word contains the adjective, noun, verb, and adjective. Right. So ultimately, it will return the tag dictionary functions, and after that, it will return us the lematize means dictionary word. Okay. So this is basically the logic behind this. So let's run it. So when we are running it, it will return this kind of the function. You can see that lemmatized word. So running is run. Easily means easily. Cats written the cat. Attractiveness written the attractive. You can see that the difference in these easily and above these easily. Right. So stemming is not performing that because stemming is removing the suffix. And here lematizer is written as the dictionary word, which is basically the contain the like real word. We can say that it's the original word and it's corresponding to the lemmatized word. So basically, this is the lexical processes, which is we have already splitting into the two parts, tokenizer and normalizer. So in tokenizer, we are splitting the word, right? And in the normalizer, we are using the two techniques, stemming and lemmatizing, where we are splitting the word like this. Stemming is basically removing the suffix from the word to reduce them into the root form. And the lematizer is returning you the dictionary meaning of that particular word, right? So that's we have seen the difference in easily and that is this easily, right? On the next topic, we are going for a syntactic analysis, syntactic processing. So this syntactic processing is basically widely famous on the task where we are using the grammatical rules of the sentences, right? So let's demystify the syntactic processing, which is unveil the grammar of the sentences. So let's embark this illumination journey of the heart of natural language processing, which is known as syntactic processing. Okay, so what is a syntactic processing in normal language? So syntactic processing basically involved meticulous analysis of the sentence structure in accordance with the rules of the grammar. So it's the key to dissecting the anatomy of the language, unraveling the intricate web of the relationship that bind word together in a meaningful phrase and the sentence. So in the normal word, we can say that syntactic processing referred to as analysis of the structure of particular sentence according to the rules of the grammar. So let's say in English language, you want to understand any sentence structure. So for that, you have to follow the rule of the grammar, right? In English. So ultimately, it's like any rule of the grammar will define the structure of any sentences. So that is known as syntactic analysis. In lexical analysis, we are trying to understand the meaning of the word, or we are converting different kind of the word into the original form. And over here, we are using the different word to make one structure of the structure of the words, right? Which is known as a sentence, but with a specific set of rules. That is grammatical rules. So it involves the understanding of how words in a sentence relate to each other and how they combine to form the meaningful phrases. Right. So here you are able to see that like a syntactic processing tree. Right. Here you can see that noun, here word processing. Right. So determinant is there, noun is there. So same way. So under these we have a we under these there are two common techniques come into the picture wherever you want to just parsing the grammars. Right. So first is a dependency grammar and second one is a constituting the parsing. So parsing with a dependency grammar is a type of syntactic processing, right? In other words, we can say that dependency grammar offers the unique lens through which we perceive the interplay between the word in a sentence, right? So it eliminates the intricate relationship between the words. So let's say that I am Asis. So it is showcasing that the relationship between I and Asis. So I am speaking, right? So this is showcasing that my name is Asis. Same way, let's say I am speaking the sentence about the dictionary meaning, normal definition of syntactic processing. So what is a syntactic processing? So I am telling that syntactic processing refer to the analysis of the structure of sentence according to the rule of the grammar. So here you can see that this sentence. On this sentence, you can see that everything. So this is a verb. Same way, you can see that accordance to, which is something known as a phrase. The rules of the grammar. So this kind of the noun, phrase, verb, determinant will make and try to make this kind of one big form of the sentence, right? And this big form of the sentence is basically known as a syntactic analysis. Okay, so in syntactic analysis, basically we are going through the two type of the method. One is a dependency grammar, second one is a constitutional parsing. So what is a dependency grammar? So basically it is a unique lens through which we perceive the interplay between the word in the sentence. So it's eliminate the relationship between the two words, right? Which is dealing, we can say that like it is a structure hierarchy that govern the linguistic expression. So, in which way you have to understand? So, let me tell you one example or imagine that, like, imagine each word in the sentence as a performer in the grand ballet, where every movement is orchestrated by its relationship with each other words, right? So, dependency passing unveil this dance and revealing the roles of each word as either a head or a dependent in the linguistic ensembles. So in the like in this journey with us, we will dwell into the mechanism of dependency passing, which is unraveling the symphony of the relationship. Okay, so here you can see that dependency passing, which is a type of syntactic structure analysis. We have already talked, right? But here in the example, you can see that we have one sentence which is known as John eats pizza. Okay, so here John is a subject, right? Eats is a basic eats and pizza is the object of the verbs, which verbs, right? And here you can see that verbs as eat is basically known as a verbs and pizza is a object. So here, whenever we want to passing the dependency grammar, which is involving the relationship between the words, we need to tree type, like we are representing it into the tree type of the structure, right? So in this code, we will able to see that how it's performing. So you are able to see that I used a spacey. So in this code, I used a spacey library where initially we are loading the English language model, right? Which is name contained English core web semantic dictionary, right? Which is basically we are doing the preload. So first, what is the first step? We have to import the spacey library. This is used for displaying the ultimately whatever the grammar we are forming, it is giving the tagging. So ultimately how we can visualize that in like how it's performing. So I use one sentence which is contain the whole ABCD. Weak brown fox jump over the lazy dog, right? Which is ultimately text object which store the value of string, right? And over here spacey.load we have created one object NLP which is contain the all the library function of this preloaded English language model. Okay, so let me talk about Spacey. So Spacey is a natural language processing library. Various NLP tasks we can do with like tokenization, part of speech tagging, dependency parsing. So over here we are using a dependency parsing. Okay. So first of all, what I had done is I had created the object of this NLP. Okay. Once I had created this object, so this is known as a basically English language model, right? This is known as English language model. We have defined the sentence. Now, I have defined this task into the four sections. First step is to we have to tokenize. Okay, so it is defined the sentence. So we have a sample sentence. We are defined into the tokenizer. Tokenizer. So what tokenizer does is tokenizer do the tokenization of each word. But how? So let's say we are passing this text object into the NLP function. Okay, and it will return the docs. Doc is basically doc is basically the object. Okay, so we can say that it processes the sentence using spacey pipeline, which is creating the doc object, right? So NLP is a spacey pipeline which is creating the doc object, ultimate return the doc object. Okay, then after here we are printing the normal text. Okay, so it will return the normal words. Text means it is returning the normal sentence like this. Okay, now let's say, so here is a tokenizer. Okay, so tokenizer is means each word. This each word is known as a tokenizer. Tokenizer is nothing but the dictionary that we have created over here, right? This is something, yeah, this is known as a tokenization. Okay, same way it is returning over here as well, but here it is returning with spacey. So here it will directly printing on this way. So the quick brown fox jump over the lazy dog. Okay, but when I say tokenizer return the word only. But here the things which you are able to see, that is a part of speed tagging. But what is a part of speed tagging? So part of speed tagging is nothing but the technique which is showcased that on the particular list, in the particular list of the sentence which is making the particular list of the words which is making one frame of sentences. So every word at particular place in the English sentence contain particular meaning, rule of the grammar meaning. Okay, so let's say the is a determinant. Okay, same way you can see that the quick brown fox jump over the lazy dog. So here you can see that the is a determinant, right? Quick is an adjective. Brown is also the adjective. Fox is a noun. Jumps is a verb. Over is a like a ADP. I don't know the formula, but yeah, you can see. So the is basically the determinant. Lazy is adjective again. Dog is a noun. That way, even you can see that it is identify the punctuation. So this way, we can just give the trying to identify the sentence. Okay, particular word contains which kind of the grammar rule it is following. Either it is adjective, it is a noun, verb, determinant, something like that. Okay, so this way we can try to identify, but how? So let's say same doc object we are calling over here, and we are just tokenizing it, every single word. So when we are printing the text, it is returning the word, but when we are parallelly where we are printing this token dot pose, right, pose, so it is returning the pose estimation list like part of speech. Part of speech means on particular part of speech, this word belonging to the which grammatical rule. That way, this part of speech tagging will work. Okay, same way, but let's say you had done this one. Okay, now you want to create the dependency parsing tree. Okay, so dependency parsing tree you want to create. So in this context, when so like part of speed tagging we had done. Okay, now let's say we want to display the dependency parsing tree text. Right. So for that purpose, we are rendering the text. Okay, so how we are rendering? We are using the display C function. You can see that display C function over here. Right. So let me use the pencil so you can understand better. So this is the display C function, which is called from the spacey itself. So with the help of this function, we are trying to render the result from the doc, this doc. Okay. Here we are providing the DEP. DEP means dependency parsing, which is trying to generate the tree from that. Okay. And it is returning HTML object. And after this returning HTML object, what we are doing is we are calling this HTML object, which is coming from the IPython library display function. Okay. So what we are doing is we are using it is finally sending the HTML object over here, and then after we are passing this HTML object into the function of HTML, and above that we are passing this HTML value into the display function, which is ultimately just create like display the image in our Jupyter notebook. How? So let me run it. Okay, so it is running this one, dependency parsing, it will doing the same, right? Fox. But let's see directly in the dependency parsing tree. You can see it's look like this. right? So, so this is a known as a rendering. So dependency parsing text is looking like this. Okay, so the is a determinant, the is a mode, brown is a mode, fox, subject jumps, root jumps, preposition jumps. Same way you can see the word, right? And this is showcasing the meaning of that, and this way we can identify. Okay, so let's say fox. So it is a main root word, okay, and this is determinant of fox. Amode, quick is a amode for guys. So same way, uh, so this is showcasing the relationship between the words, nouns, and the verbs, even sometimes adjectives. So this is showcasing the relationship. So jumps, prepare to over the lazy dog, right? So this is showcasing the prepare, then over means whom, over whom. So let's say dog, the lazy dog. Okay, so it is also showcasing the determinant of the dog, and which kind of the dog, the lazy dog, something like that. So this way it is parsing the grammatical rules. Like a computer is understanding on these ways, so that's why syntactic parsing importance is there. Second one, second one is basically known as constituting parsing and dependency grammar. Okay, so in these, basically, constituency parsing is also known as phrase structure parsing. Okay, so phrase structure parsing, like we can say that like it's a dwell into the hierarchy structure. Right, it is dwell into the hierarchy structure of the sentence, which is deselecting them into the constitution part based on the tenets of the formal grammar. Like imagine that like an artist, like artisan crafting the tapestry, so which is constitution passing the waves together, the constitute element of the sentences, which is delineating the noun phrases, verbs phrases, and their intricate relationship. So basically, constitution passing in simple form, we can say that it is a phrase structure passing where we are focusing on identifying the constituent and the phrases in the sentence. Okay. So in the tree, you can see that we are break down each constitution part. So in the sentence, you can see that we have a one sentence which is known as the cat chased the mouse. Okay. So let's parse in that. So first of all, it's passing into the sentence. It is breaking down the noun and the verb. Okay. So inside the noun, you can see that we are breaking down into two more things. The cat. The is a determinant and cat is a noun. Okay. And verb. Verb part, we can see that like chase. Chase is basically known as a verb. Right. And also it's showcasing the chase. Right. Same way, the is also the verb of mouse. Right. Sorry, it's a determinant, not the verb. Okay, and same way we are using the verb parsing, also parsing into noun. Now, why noun? Because here you can see that mouse is basically known as a noun. Okay, so these way the sentence or phrase parsing we are doing on that way, because sometimes we are defining this like a big sentence. Okay, on that sentence, this kind of the phrase parsing we can do. Okay, so in constitution parsing, sentence basically divided into the noun phrase, verb phrase, and further into the constitution part such as a determinant, noun, verb. This is known as a constitutional parsing, right? So in the code, let me tell you, in this code, basically, what we had done is you can see that we have used spacey first of all. Same, we are rendering that output, but here we are rendering on the different way. Okay, I loaded the same English model over here. I have used one sentence, the cat is the mouse, and same way you can see that I use NLP object. Okay, and where I pass the sentence. Okay, so ultimately it return the doc, right? A dog, spacey dog object. So that spacey dog object is basically spacey dog object containing the linguistic annotations, right? Next is you can see that token and post tagging. So as you already know that, right? Previously we have seen like we are taking from the doc we are taking the tokens and we are create the list of that tokens. So token list will be ready by using this code. Same way, doc is also returning us preloaded post tagging, right? Post tagging list we are also making by extracting the tokens and post tagging from this. Okay, now you can see that this one, right? Cornell format. Okay, so here what exactly happening? So this string, what you are able to see over here, this string representation of constitution parts in the conal format. So what is the conal format? So when we are talking about the conal format, so this is something like, uh, let me showcase you the conal format. So this is a universal dependency passing format in the constitutional form. Okay. So this conal format is basically create the associated part of speed tagging. Specifically, it is used for the NER, different kind of the purpose. Right. So this is a universal format for annotating the text. Right. Conal U, conal X, there are multiple variants. So this is used for the part of speed tagging. Okay. So here we are using that conal format and we are separate out the token, pose. So this is something kind of creating the constitutional parsing tree. Okay, so here T word like T slash N, which is a kind of giving the space to the word or something like that. Okay, by taking the different word over here. Okay, and ultimately it is generating the conal format of output. Now let's say we want to render this output. Okay, in the different format this time. Okay, so here what we are using that here with the help of display C, right? So here the content like a display C render function is returning us the HTML content, right? So here it generates the HTML content which is representing the constitutional parse tree. Okay, so let me run the first. It is returning or not. Let's see. So you can see that it is returning this way. Okay, so what I had done over here, I used the display render function with some style and compactness, background color and text color. Okay, so here you can see that there is some option where you can set that compact. So it's showcasing the compact tree. Background is here. You can see that we have a used blue background color. Okay, with a white lining and all. Okay, so font style, font color, and line which will be drawn in the white. Okay? It will be display. So these way syntactic parsing is working. Okay, and this will returning the output. So here you can see that the cat chased the mouse. So the cat. So what is the cat determinant? So cat determinant is a the. Okay, then chase. Right, so subject is trying to chase someone. Okay, so which whom to chase? So it is trying to chase the this noun. Okay, so the noun is mouse. Okay, but mouse has their own determinant, which is known as a the. So this way we are trying to passing the syntax, and this way computer is trying to understand. Okay, this is an English language, so I call this cat as a noun, chased as a verb, the as a determinant, mouse is a noun, same way, right? So these are the multiple techniques in syntactic processing. So let's summarize this syntactic processing again. So syntactic processing basically defined into two parts. But what is syntactic processing? It is nothing but the analysis of the structure of the sentence according to the rules of the grammar. Okay. It is defined into the two parts, basically the dependency grammar and constitutional parsing. Dependency grammar is basically nothing but the type of syntactic structure analysis where we are focusing on the relationship between the words in a sentence. Okay, relationship between the word in a sentence. Okay, basis on the grammatical rule where we are using the post tagging technique which is known as a dependency parser. So here we are using basically the three-step process. First to tokenize, second to part of speed tagging, and third one is dependency grammar. So once it will be done, we are render that with the help of display render function. Same way we are doing for the constitutional parsing, which is the second part. So what is the constitutional parsing? We are constitutional parsing is known as a phrase structure parsing, right? Where we are trying to extract the phrases, right? Phrases or hierarchical relationship between them. So how we can do that? Again, same step. We are doing the chunking. First step is chunking. Second one is post tagging, and third one is we are converting these into the one of the universal format. So here, constitution parsing format is we are using corner. So whenever you want to see the other format, constitution parse different techniques in NLP. Whenever you do Google, you will see the multiple techniques is there. Okay, and you can learn that technique. So constitution parsing, top down and bottom up, you can see. But there are multiple techniques you can explore by your own self. Okay, I will not dwell into the deeper one. But yeah, Cornell is one of the popular formats that we are following on this course. Okay, so in these you can see that we have designed that which is returning into the format, and then after, so first step is to just tokenize post tagging, and then we have to convert into the corner format, which is a constitution parsing tree. And once it will be done, we are passing this format into the for the render purpose. Okay, and it will generate the result output like this. Okay, guys. So this is a today's session, right, which is cover the basically of the syntactic parsing, syntactic processing, and first one is a lexical processing. So this is a hands-on, and let's say you want to do the practice, so you can go on the LLM crash course GitHub. Okay, these two notebook is available over there on Lexical and Syntactic. You can go over there and you can just directly click over there and you will get these two notebook. Okay, so you can run by your own self and do hands-on. Okay, and even the theory is also written there to make you understand more better way. So we will conclude today's session. On the next session, we are covering up with this semantic processing and the pragmatic processing. Okay, and then after on the last session, we will cover these work representation embedding, these all the things practically. Okay, so stay tuned until the next session. Thank you.